Hello, once again, welcome back to STA 2306, Data Analysis for Statistics. Previously, we looked at the causal trend. We also looked at the even numbers, even functions and odd functions, and we're able to check on the properties. We checked on the integrating odd functions of a symmetric domain. For instance, maybe from negative p to p. The same way to the even functions. Then we checked some few graphs. Then we also checked on the periodic functions. And we given a good example of a periodic function as the trigonometric functions, because we say they have repetitive behavior. So if you can check on the final statement that we said, for instance, maybe sine pi x and cos pi x, they have a periodic of 2. So, and for sine x and cos x are period with, they have a period of what? 2 pi. We said a period, it is maybe if you can go a little bit to physics, you say that period is the amount of time taken to complete one oscillation or even one cycle. Now, if maybe I can put a final comment here, if L is a fixed point, the fixed point or fixed number, I'll just say maybe is a fixed number. The fixed number, then sine 2 pi x over L and and cos 2 pi x over L have a period L. And so from that, let us look at our second lesson now today on Fourier series. Fourier series. Now, what's a Fourier series? A Fourier series, we have spoke of different series. We have seen there is geometric series. We have seen there is arithmetic series, and other series that maybe have come across. When we speak about a series, we can't forget to talk about a sequence. So from what we know is that a sequence is simply maybe the elements or items or numbers which have been arranged in a certain order, either ascending or descending, or there is an order that is being followed. When we speak about a sequence, a series, then we're speaking about a sum of the elements of a sequence, right? Now, when now we speak about a Fourier series is simply a series that has been, it's a series of trigonometric functions, that is sine and the sine and what? The cos. Now, so we can write this and say, let's write and say, we say that a Fourier series is an expansion is an expansion of a periodic. It's an expansion of a periodic function x, function f of x, in terms of in terms of an infinite, in terms of an infinite sum of sines and cosine, that is, and cosines. And so when you speak about a sum like that, then you say that a function expressed, a function of the form function expressed in form of f of x being equal to a naught plus summation of an cos nx plus bn sin nx ux. For this n is running from 0 from 1, that is, this n is running from 1 infinite, where a naught, an, and bn are constants. Constants is known as Fourier series. It's known as Fourier. It's known as Fourier series. Now, I want us to recall this one. If maybe we can expand f of x. If you expand f of x, you're going to have f of x is equals to, this one it is a naught plus, now when n is equals to 1, you're going to have a1 cos x plus a2 cos 2x plus a3 cos 3x, like that. Then plus b1 sin x plus b2 sin 2x plus, like that. So you can be able to see this one is simply the expansion. Now we say that I call this one equation 1. We continue and say the series equation 1, series equation 1 is called a trigonometric series. Trigonometric series, or now still what is called what? Fourier series. Because that's what you have said in the above statement. It's a Fourier series. And it turns out that that expressing a function, expressing a function is Fourier series is sometimes advantageous, than expanding it as a power series, than expanding it as a power series. Now, we need to obtain the coefficient A naught, AN, BN. So we start by assuming that geometric series and says that that geometric series converges it has a continuous function of x as its sum on the interval on the interval from negative pi to pi. So, and this you can write and see, like that is maybe f of x is equals to a naught plus summation of an cos nx plus bn sin nx, and for this n runs from 1 to infinite, and the domain of x for x is in between from negative pi to pi. And I want us to call this one equation 2. Equation number 2. So we want to obtain now the coefficients now in terms of the function f. So obtain the coefficients a naught, an, and bn in terms of function f of x. Function f of x. So start by integrating both sides of equation 1. Not equation 1, equation 2 now. We already have the equation 2. So integrating both sides of the equation 2 with respect to x, we're going to have the integral of f of x dx equals to the integral of a naught plus, so this one still also dx. So with respect to x, dx plus the integral of summation of an cos nx plus bn sine nx, again with respect to x. Now we have said this n is running from 1 to infinite, and the domain of x is from negative infinite, negative pi to pi. So this x is running from negative pi to pi. So our integral limits will be negative pi to pi. Also this one negative pi to pi. Now, I want you to remember that what we said about uh, integrating an odd function over symmetric domain. Like in this case here, our limits are symmetric because we are moving from negative infinite, negative pi to pi. So it is symmetric about the y-axis or about 0. Now, and also again, something else that you should remember, that when you multiply, or maybe the product of an odd function and even function, we said it's what? We said it's also odd. If you can come back a little bit here. So the product of an odd function and even function should be an odd function. The product of two even functions is even. The product of two odd functions is also odd. And you see that a good example of an odd function is sine x, and then we have cos x as an even function. Now, so this equation, you can call this equation, let's just call this equation number 3. So, so you're going to use this equation number 3 to obtain the value of what? A naught. Now, we go say that first, let us just integrate this one, this equation. So you're going to have the integral from negative infinite to infinite f of x dx is equals to what? When we integrate this one, we shall get a naught x from negative pi to pi, and then you have plus the sum for n from 1 to infinite, the integral from negative pi to pi of an cos nx dx plus the integral of, in the sum, because we're opening the bracket in the sum, the sum from n equals to 1 to infinite, then the integral from negative pi to pi of bn sine nx dx. Now, if you can integrate, if you can substitute the limits here, you're going to have the integral from negative pi to pi f of x equals to, so substitute the upper limit here, will become a naught pi minus a naught pi. So you're going to have 2 a naught pi, the 2 a naught pi, and then plus, have you understood how we have done the substitution, just like this. Maybe I can put a different color here. When you substitute this one here, you get the upper limit, you get a naught pi minus a naught negative a naught pi. So this negative and this negative is the one which is in the pi, negative pi as the lower limit. We take the upper limit, minus when you substitute the lower limit. So this one to become plus, negative and negative will become plus or positive, and still therefore we're going to have a naught pi plus a naught pi. That will end up getting to a naught pi. So this one here should be 2 a naught pi to a naught pi plus the sum n is equals to 1 to infinite, then the integral from negative pi to pi a n cos n x x plus summation n is equals to 1 infinite, the integral bn, the integral from negative pi to pi, negative pi, pi, bn sine nx dx. But if we integrate these ones, we're going to get what? So the integral, what will be the integral of, you know that the integral from negative pi to pi of an cos nx dx is equals to what? This one is equals to 1 over n sine nx. Then this one will rise from negative pi to pi. And so this one here gets what? You end up getting, this one will be equal to 1 over n, going to have sine n pi minus sine negative n pi. So we know sine n pi is already 0. So the difference here is still be equal to 0. Because for instance, maybe if you can have what is sine pi, remember pi, it's 180, sine pi is equal to 0. So sine 2 pi will still be equal to 0. So sine n pi is equal to 0. So our sine n pi will be equal to 0. Then then what about this other side? You can also have so, and also again for the same case that will apply to cos n pi, the cos n pi to be equal to, you can have it here, the integral of an that is bn, the integral of bn bn sine nx dx is equals to negative 1 over n cos nx, the integral from negative pi to pi. So also this one will become what equal to what? So you're going to have negative outside and have negative 1 over n Then I can have now cos n pi minus cos negative n pi. Remember, cos negative x, they're the same as cos x. So this one does not change. So meaning that this one we still have, we're going to have negative 1 over n into bracket cos n pi minus cos n pi. And so cos n pi minus cos n pi will be equal to 0. So the integral of Bn, and if you sum zeros, you still get a 0. So that's why you're not going back to the series to substitute cos, to substitute the zeros. This limit it from negative infinite, negative pi, pi. So and this one also becomes equal to 0. So this implies that our series, our equation 2, will return to B, and so the integral from negative pi to pi f of x dx is equals to 2 a naught pi. So make a naught the subject, making a naught subject. We have a naught equals to what? It will be equal to 1 over 1 over 2 pi, the integral from negative pi to pi f of x. So you can have this one here as 3. So I need this equation number 3. Now, to determine an, to determine an for n is greater or equal to 1. So we multiply both sides. Multiply both sides. Both sides of equation 2. Equation 2 by cos mx. By cos mx. Because mx, where m is an integer, where m is integer, m is an integer greater or equal to 1. Then integrating both sides. Then integrate. Then integrate term by term. Term by term over the interval negative pi. So that is from negative pi to pi. Pi to pi. So the same thing that you are doing. So when you integrate equation 2, you're going to have so the integral from negative pi f of x dx is equals to, and now we have already multiplied, so we have said we multiply by cos mx. Cos mx dx is equals to the integral from negative pi to pi a naught plus b, what b, plus an summation of cos nx plus dn summation of sine nx, then have cos mx, then dx. So this implies we're going to have a naught. So this side is just going to remain the way it is. So I can say is equals to a naught, a naught, then integral of cos mx dx. And this one is from negative pi to pi. It's a symmetric domain. Then plus an n sum, n stands from 1 to infinite. Then the integral of cos mx cos nx dx, then plus dn sum of, and this integral also runs from negative pi to pi, then the integral of from negative pi to pi of sine nx cos mx dx. So sine mx and cos, this one it is mx. So here is this one that I'm not going to do. Now cos x cos cos ax, or maybe cos nx, we said it's what? If cos x is an even function, then you can talk about, there are some integrals here that are going to diminish. So you can say that we have seen that. You have seen before, you have seen that. That first integral equal to 0. That first integral will be 0. And the reason why it will be 0, because it's what? So if you can come back to this, what the integrating an odd function. Integrating an odd function over symmetric is what? It is 0, right? So, and we said an example of an odd function. A good example of an odd function is what? I just want to bring it up here. A good example of an odd function is sine. And again, we said the product of two odd function, or maybe the product of a two odd function is still it's an even function. Then the product of two even functions is also even. Otherwise, when you multiply or need the product of an even and odd function, you get an odd function. So from that, you can write and say, you still have that is 0. Also, the integral from negative pi to pi sin nx cos mx x equals to 0. This one is for all n and m. This one will be equal to 0. And also again now, the integral from negative pi to pi of cos nx cos mx dx. This will be equal to 0 for all n not equal to m, and to become equal to pi for all n equal to m. So, and therefore, the only non-zero term in equation 4 is am pi. So you're going to have say that the only non-zero term, the only non-zero term in this equation 4. So the equation 4 simply it's this one. Let the equation 4. So in equation 4 is am pi. So, and we have on the right hand side remains am pi on the right hand side. So we did not touch the left hand side, and so you're going to have the integral of f of x cos mx. Remember, there's no way saying that it is an pi, because it can only be when n is equals to m. So if this m is equals to n, then you're going to have cos mx. So, and when you integrate that, you shall get, when you solve that, you shall get what? Shall get pi. And if it will be pi, then you're going to have an, this one here, an, and the whole of this part here, it will become pi. Remember, pi is a constant. So the sum of pi's from 1 to infinite to still be pi. So that's why you remain with an pi. So it's equals to am pi. And this pi, and this integral here runs from negative pi to pi. So this implies that for m or n, implies that, okay, if you make am the subject, so this implies that you're going to have am being equal to 1 over pi, the integral from negative pi to pi f of x cos mx dx. There's a dx here, dx like that. Now, so for n, if this one here it is m, so if you could just substitute m and n, because I've said it only appears when n and m are equal, then you can say that for n is equals to 1, 2, 3, moving forward, then an is equals to 1 over pi, the integral from negative pi to pi f of x cos mx dx. And I want us to call this one question number 5. This is question number 5. Now, we want to obtain now the Bn, and to obtain the Bn, we need again to multiply equation 2 by sine nx. So we say that if we multiply equation 2 by sine mx and integrate from negative pi to pi, then uh, with respect to x, then we shall get dn as equals to 1 over pi, the integral from negative pi to pi f of x sine nx. So, and this we didn't need to prove because we have already proven the part for for an. So, and we just use the same procedure to obtain bn. This one is for n equal to 1, 2, 3, going forward like that. Now, so we can just say now in summary here, if we rate f of x be a piecewise function, be a piecewise continuous function, that is a continuous function on the closed interval with pi to pi, then the Fourier series of f of x given by x equals to a naught plus the sum n is equals to 1 from n is equals to 1 to infinite an cos nx, then plus bn sine nx, where a naught you have said is equals to 1 over 2 pi, the integral from negative pi to pi f of x dx. We have an equal to 1 over pi, the integral from negative pi to pi f of x cos nx dx, and we have bn being equal to 1 over pi, the integral from negative pi to pi f of x sin nx dx. They defined a naught, an, and bn are called beta coefficients of f, are called Fourier coefficient f of x. So let us look at an example. Example. Find the Fourier coefficients and the Fourier coefficients and the Fourier coefficients and Fourier series and Fourier series of the equation of the Fourier series of the square wave of the square wave function x f of x defined by f of x is equals to 0 if x stands from -5 to 0 and it's equals to 1 if x runs from 0 to positive pi. So this is what we call a piecewise function that does not have that it does not have finite discontinuities. So solution. So we need first of all to state our Fourier series form of f of x. So we know that f of x is equals to a naught plus the sum an cos nx plus bn cos bn sine bn sine nx, and this n runs from 1 to infinite. It's given that a naught is equals to what? A naught equals to 1 over 2 pi, the integral from negative pi f of x dx. Then am, you said an equals to an is equals to 1 over pi, the integral from negative pi f of x cos nx dx, and we have bn being equal to 1 over pi, the integral from negative pi to pi f of x sine nx dx. That one is the bn, and so from the above question, can now obtain our a naught. Hence, our a naught is equals to 1 over 2 pi, the integral from. Now, if you can see, we have two intervals from negative pi. Okay, fine. I can just say from negative pi of f of x dx will be equal to the same as 1 over pi, 1 over 2 pi, 1 over 2 pi, the integral from negative pi to 0. And from negative pi to 0, our function is equal to what? to 0. So we're going to have 0 dx plus the integral from 0 to pi, the value, or maybe the function at this interval is 1. So you have 1 dx. So what do you obtain here? When you solve this one, we'll get what? So this first part will just be equal to 0. So we remain in the second part. So we're going to have our a naught is equals to, so this first part here will be 0. So we're going to have x, which runs from 0 to pi. And remember, we have 1 over 2 pi. So this one will be equal to 1 over 2 pi. Then you have the pi. The pi, so maybe substitute this pi to x, then minus 1 to 0, so you get pi. So that pi and that pi goes, so we have our a naught being equal. Now, we need also to obtain an, bn. So for the an, we have said an equals to 1 over pi, the integral from negative pi to pi, f of x cos nx x. That being the case, so this will be equal to, this implies that our an will be equal to 1 over pi. So we integrate again the integral from negative pi to 0, which is just 0. Our f of x will be 0. Then cos nx dx plus the integral from 0 pi, which is 1. Then cos nx dx. So if we solve this one, we're going to obtain our an being equal to, this first part here will be equal to 0. This part will be equal to 0. This one will go to 0. So we're going to have 0, 0 plus. So if I integrate this part here, I'll get what? 0 plus 1 over, will be 1 over. So remember, outside here we have 1 over pi. So the first part will be 0, then plus 1 over n sine nx, which are from 0 to pi. Now, if you substitute pi, what are you going to get? If you substitute pi here, you get 1 over pi, 0 plus 1 over n sine n pi. Sine n pi is equals to 0. So sine n pi is equals to 0. That's the same way we say sine. We know that pi radian is 180. So sine 180 is equals to 0. So if I multiply that 180 by 2, 360, sine 360 is equals to 0. I multiply by 3, I still get equal to 0. So this implies that an is equals to 0. Then for the bn, so we know that clearly bn is equals to 1 over pi, the integral from negative pi, f of x sine nx dx. So we can substitute, say that this one here is equals to can now say that a bn is equals to 1 over pi. Then we'll have this integral from negative pi to 0. Our f of x is 0, so you're going to have 0 sine nx dx plus the integral from 0 pi f of x is what? It's 1. Then sine nx dx, like that. Now we can integrate. You know the first part is going to become equal to 0. This first part here will be equal to 0. So we're going to remain with, shall have our bn being equal to negative 1 over pi, not negative, still pi, 1 over pi, 1 over pi, then the integral of, from the integral from 0 to pi of sine nx. So this one is equal to what? So this will be equal to 1 over pi. So when I integrate sine, I'll get negative 1 over n cos n pi nx from 0 to pi. So this one I'm going to get bn is equals to, now we'll substitute pi. So let me just get out negative 1 over pi. I can have negative 1 over n pi. Then I can have now cos. I now have cos n pi, or yes, n pi, cos n pi minus cos 0. So cos n pi is equals to what? So cos 0, you know that is equals to 1. But what about cos n pi? Cos n pi, when n is equals to 0, shall get 1. When n is equals to 1, then we shall get cos pi, which is equals to negative 1. So bn, you're going to get a piecewise. So you realize that bn will be equal to 0, to be equal to 0 if this n, if the n here is even. So if n is even. Why? If I put 0 here, when n is equal to 0, I'll get cos 0, which is 1. So cos 1 minus cos 0. Cos 0 is also 1, so 1 minus 1 would be 0. So it is 0 when n is even. And when it's odd, we shall end up getting 2. So it will be 2 over n pi. 2 over n pi if n is odd. If n is odd, then shall get 2 over n pi. What are you saying like that? If maybe n is equals to 1, 1 is odd. So if n is equals to 1, you have said we are going to get, I'll just use a different color. So if n, when n is equals to 1, inside the bracket, I'll have cos pi minus cos 1, cos 0, that is. So inside this bracket, I'll get cos 180 equals to negative 1. So it will be negative 1 minus 1. So which is equals to negative 2. So this negative 2 multiply by negative 1 over. So we have negative 1 over n pi multiplying by negative 2. So negative and negative will become positive. We shall have negative 2 over n pi. And so therefore, so this one is just a showcase on how you're getting that piecewise function. So you can say, and now say, if you substitute, you're going to have, we have our x, if you expand our f of x, remember f of x is equals to a naught plus summation plus, I can take my an outside, then have summation of cos nx, then plus dn summation of sin nx, and this n is running from 1 to infinite, n is running from 1 to infinite. So my a naught is a half, we got it a half. So our f of x is equals to a half plus, now in this case, we have our an. What's our an? Our an was 0. So if it is 0, we multiply by summation of cos nx. The whole part will become 0, then plus, then you have bn. We got bn is equals to bn. We have some different values, so bn have 2. It can only be 0. It will be 0 if n is even, so meaning that we must have a condition that n must be odd. And how do we get odd? If 2k is even, then if I just say 2k plus 1 will be odd, right? Yes. Like for example, we know like 4 is even. So if I just add 1 to this 4, I'll get 5, which is what? Odd. So we're going to have 2 over n pi, then sum of what? Sum of sine n pi, like that for this n. For this n, we're going to put some condition here. So if I just expand this one, I'm going to have f of x is equals to 1 over 2 plus, so this part will be 0. The whole of it will become 0. So you're going to have, when n is equals to 1, you shall have 2 over pi sine pi, right? Then plus, when it is 2, you shall have 1 over pi, then sine 2 pi, right? So you're saying that, and then if you just continue, we can have, you have 2 over 3 pi. So we have, yeah, 3 pi, you better just have it here. So remember, this one is just the sum. It have 4 pi, then 2 over 3 pi. Why are you saying like that? Because remember 2 over pi sine x, they're the same as 2 over n pi sine x, right? Then plus, substitute again here, you can substitute 2. Now you substitute 2 here, you substitute now 3 plus 2 over 3 pi sine 3x, not pi, it's sine 3x. So you can just erase this one. This one is nx, it was not supposed to be n pi. It's nx. Erase all of them, this one, 20 is x, the 20 is x. This one being, if you put pi, it will just become 0. It will become 0, and so forth like that. So remember, I put a condition that it should not be an even. So you can see here, this one it is even. So this one, when it is even, this one will become what? 0. So we're going to pick when n is what? odd. So that is 2 over pi, 2 over 3 pi, 2 over 5 pi, like that. And so, since odd integers can be written as, since odd integers can be written as n is equals to 2k plus 1, or maybe 2k minus 1. Either way, you can, it will be 2k minus 1. 2k minus 1. K minus 1, where k is where k is an integer. So we'll get our Fourier series written in form of we can write Fourier series the Fourier series now in sigma form, in sigma form or notation s f of x being equal to 1 over 2 plus the sum k lines from 1 to infinite, then now 2 over, so it was 2 over n, so we can put our n as what? 2k minus 1 pi, then sine 2k minus 1 x, right? So that one becomes our Fourier series. So next by evening, I'm going to send a video for Fourier convergence theorem. So I shall start on Fourier convergence, convergence theorem. Thank you and have a good day.